Hi, I'm Cyrus Vachha, and I'll be presenting our work, Dreamcrafter, Immersive Editing of 3D Radiance Fields with Flexible Generative Inputs and Outputs. This work was completed during my master's at UC Berkeley, along with my co-authors Yixiao Kang, Zach Dive, Ashwat Chidambaram, Anik Gupta, Eunice, and Bjoern Hartmann. There's a long-standing vision of being able to create large-scale, realistic 3D worlds, but how can we approach this? In our work, we believe that recent advancements like Radiance Fields and Generative AI can make this vision closer to reality. We introduced Dreamcrafter, a VR world-building system for creating photorealistic 3D scenes using Radiance Fields and Generative AI, with proxy representations enabling real-time natural language multimodal interactions. Creating and editing photorealistic 3D content has traditionally been a challenge in spatial computing applications, HCI, and computer vision research. Two recent advancements have now made it possible to achieve this with greater ease. First, 3D representations like neural radiance fields (NeRFs) and 3D Gaussian Splatting have enabled photorealistic rendering of real-world scenes with higher fidelity than traditional mesh and texture methods. Second, Generative AI has introduced multimodal semantic level generation of images, 3D, and other forms of media. While powerful, these approaches lack controllability and are not always suitable for real-time use, paired with limited text-based inputs. The challenge we address is how do we unify these complementary strengths, the immediacy and control of direct manipulation, with the semantic power of generative AI editing applied to 3D scene world building to enable natural language interactions and lower barriers for novice users. In our review of related work, we've seen advancements in representation techniques and generative models, but usability challenges still remain. Research systems like NeRF Studio and InstantNGP are only designed for training and building upon these 3D representations. Current radiance field editing and generative approaches are primarily limited to text-based interactions and occur high latency and lack core functionalities expected in regular 3D editors. Systems like Worldsmith and commercial platforms like Luma Dream Machine and Runway offer multimodal interfaces with iterative design processes, but remain non-immersive and limited to 2D image or video outputs with chat-based interfaces, currently lacking support for 3D content creation. Unlike these approaches, our work focuses on immersive interactions with spatially persistent scene creation tools for 3D environments. XR tools have explored world building and generative AI in virtual environment creation. However, these don't support radiance fields or focus on using generative models for creating realistic outputs. Now I'll be discussing the design and key interactions of our system, followed by our evaluation and user study, and then I'll conclude with some remarks on the relevance of Dreamcrafter to future systems. We designed Dreamcrafter to be a photorealistic scene editor to support realistic captures of objects to also unbounded scenes. To achieve this, we designed our system to support radiance fields, specifically Gaussian splats. We also wanted to support interactions at different levels of controllability afforded by generative AI models. We support interactions with direct manipulation for certain tasks requiring fine-grained control and natural language instructions or prompting for higher-level semantic interactions. Since advancements in generative models are very fast-paced, we design our system to support current and future models by creating a modular architecture with standardized inputs and outputs. Since some operations incur high latency, we introduce proxy representations to support real-time interaction for visualizing the outputs. With Dreamcrafter, we design a 3D editor that supports current radiance field technologies with a design space that supports interactions with high and lower levels of abstraction, generalizable to future 3D representations. Dreamcrafter offers a spatial annotation system that allows users to perform and preview edits to the scene with real-time feedback by interfacing with task-specific modules for 2D and 3D generative tasks. We introduced the key interactions for editing and generating objects. Traditional tools are incompatible with these new representations, and existing approaches either lack real-time feedback or don't provide intuitive controls. We developed interaction techniques by analyzing limitations of emerging 3D representations and focusing on natural language prompts and multimodal inputs. With VR controls, users can position, rotate, and scale radiance field objects with direct manipulation. We align meshes with Gaussian slats to enable physics and collisions. Users can edit selected radiance field objects using voice commands with natural language instructions for stylistic or basic structural changes. The system generates quick 2D previews using Instruct Pix2Pix, offering 3 variants. Full 3D edits are processed offline with Instruct Gaussian Splat to Gaussian Splat. Dreamcrafter offers 2 methods to generate objects. Users can generate objects using voice prompts. This stylizes the render to make a photorealistic image outputs. Users can also select from 3 variants to place a 2D proxy preview as a spatial annotation, with the full 3D object generated offline using text to 3D or image to 3D systems. Alternatively, for more controllability in generation, users can generate objects by sculpting with basic 3D primitives to create a coarse, low-fidelity 3D form and then provide a spoken prompt. The system stylizes it using a depth-conditioned image model with the user's spoken prompt. The full high-fidelity 3D object is then generated offline based on the stylized image using image to 3D modules. We also introduced the Magic Camera, a feature that allows users to position a virtual camera within a scene and generate a stylized image from a snapshot based on a text prompt. Using an image stylization module like ControlNet, the Magic Camera outputs and reflects a coherent and realistic composition implicitly, considering the spatial arrangement and content of the scene. The 2D output can be used in image-to-video models for controllable AI-generated video sequences or input into image-to-3D systems to create 3D scenes. This enables an iterative workflow where a user defines a scene layout through Dreamcrafter, stylizes it with the Magic Camera, and then refines the resulting 3D scene for further design and editing. Dreamcrafter contributes the use of proxy representations and spatial annotations for providing real-time feedback to users to allow for rapid iteration. These proxies include label and image previews where 2D generative models are used to visualize time-consuming 3D operations. After the user edits the scene, using the JSON file logged by the spatial annotation system, Dreamcrafter processes the edits and generations offline after the user finishes editing in VR. Once processed, objects are replaced in the scene, allowing for users to re-edit them, enabling an iterative design process. Dreamcrafter is built as a Unity app which interfaces with API calls to generative modules through a C# and Python Flash server pipeline, allowing inputs from Unity to process in real time and output results into the Unity app itself. Gaussian splats are rendered using an open source Unity viewer trained with Nerve Studio's SlatFacto and Luma AI. We conducted user evaluations motivated by research questions for when do users choose to generate objects via prompting versus via sculpting, and how do users react to the proxy representations. We conducted a study with 7 participants who completed 3 scene editing tasks. Despite some technical challenges, all participants expressed interest in using Dreamcrafter for future projects ranging from CAD or to interior design or to video game development. When asked, participants explained prompting was easier and faster. We found that users found both direct manipulation from sculpting and natural language-based interactions from prompting valuable for 3D scene creation. Some participants used the system's generations as inspiration for future creation, while others preferred fine-grained control to minimize unintentional results. Both approaches serve different purposes in the design process, and supporting both forms of control is necessary to accommodate diverse creative paths. Most users found proxy representations helpful for both composing the scenes, however, some were uncertain about the final scene appearance. Users would also reposition the proxy objects in the scene after generating and would sometimes iterate the object appearance based on the output of the proxy. We discuss additional evaluation results in our full paper. We believe Dreamcrafter has the potential as a world creation and staging tool for other generative AI models. This approach of using low-fidelity inputs and using generative models to create high-fidelity outputs offers more control for video and scene generation. We envision Dreamcrafter to be a system for assisting in the creation of realistic environments and worlds for future 3D representations. In order to approach this goal today, we created an immersive Gaussian splatting editor with multimodal generative models. Dreamcrafter could serve as an early exploration into spatial prompting systems that offer more control for 2D, 3D, or video scene generation systems beyond limited text prompting interfaces, which are currently in state-of-the-art consumer applications. Users can iterate quickly at high abstraction levels with low-fidelity representations and can generate various high-fidelity outputs using generative models, including for staging scenes for video generation models. We envision extending our system to enable large-scale 3D environment generation and editing, leveraging future 3D representations like video and implicit 3D editing with natural language instructions and gestures across different levels of controllability. With recent research companies exploring world-building systems, we hope our work informs the development of these future systems and broader computer vision and world generation research directions. In conclusion, Dreamcrafter combines direct manipulation for spatial positioning with generative AI for editing style and appearance. To address AI latency, we introduced proxy representations, using 2D diffusion models as stand-ins. Our user studies showed participants felt more in control when sculpting before AI stylization and found proxies valuable for scene editing. This approach points towards new possibilities for world-building systems and creative generative AI-assisted tools that blend direct manipulation with generative AI capabilities. For more information, check out our project page, and please refer to our paper for additional details. Thank you.